In the last video, we talked about the layers of the atmosphere. This time, we're looking specifically into pressure and density. So, come along with your favorite hippie to learn some stuff. Right now, air is pushing on you from above, from below, even from the sides. That force is called air pressure, and it's the reason weather can exist at all. Without pressure gradients, there would be no wind, no storms, and no large-scale weather patterns. Air pressure is the force exerted by the weight of the air above a given point. Every molecule of air has mass and is pulled downward by gravity. On a molecular level, pressure comes from countless collisions between air molecules and surfaces. As altitude increases, fewer molecules are present, so collision frequency and therefore pressure decreases. Pressure isn't caused by air pushing downward, but by the cumulative weight of the atmosphere above. Atmospheric pressure decreases exponentially with height. This means most of the atmosphere's mass is concentrated close to Earth's surface. Roughly half of all atmospheric mass lies within the first 3.5 miles, or 5 to 6 kilometers. This vertical pressure gradient is why weather is confined to the troposphere. Density describes the mass of air within a given volume, or how tightly packed molecules are. For gases, density is controlled primarily by temperature and pressure. When air is heated, molecular motion increases, spacing between molecules grow, making density decrease. This relationship explains why warm air tends to rise and cool air sinks. Rising air isn't just pulled upward necessarily, it's displaced by denser surrounding air. An easier way to explain this is kind of like a suction, but it's really just air displacement and replacement. Atmospheric motion begins with buoyancy. When air is heated, its molecules move faster and spread apart. As molecular motion increases, it lowers its density, making it buoyant. This vertical movement is the beginning of atmospheric circulation. This is the same convection idea we touched on earlier in the first video, but if you haven't been following along in the series, I'll have it linked right about here. Areas of high pressure form where air is cooler and denser. Areas of low pressure form where air is warmer and less dense. Air naturally moves from high pressure towards low pressure, and we experience this as wind. It's kind of like rolling a ball downhill. The ball doesn't necessarily choose to move, it's the slope that makes it inevitable. Wind is the atmosphere's attempt to restore equilibrium. The greater the pressure difference, the stronger the wind. This is known as the pressure gradient force, and it's the primary driver of atmospheric motion. Pressure and density explain why air begins to move, but Earth's rotation determines how that motion is organized. In the next lesson, we'll zoom out and look at how these movements organize themselves into global circulation patterns. Stay nerdy!